Okay. See, in first year syllabus you have two chapters. One is what? General organic chemistry. There we will be studying very basics of organic chemistry. Okay, then next hydrocarbons. These are the two chapters from first year chemistry. And then next whatever the other remaining organic topics are there, all of them are from second year. What are the chapters are there? Haloalkanes, haloarenes, alcohols, phenols, ethers, aldehydes, ketones, carboxylic acids. Next amines like nitrogen containing compounds. Okay, these are the topics to be discussed here. Okay, so firstly, if you follow the next two lectures, today we will be beginning, like in order to solve any organic question, you need to have proper understanding of general organic chemistry, especially like electronic effects will be there, like inductive effect, mesomeric effect, hyperconjugation. Have you heard these words? At least one or two names. Yeah. So if you understand this very very clearly, you can solve maximum number of questions. Without knowing the names of the reactions also, you can easily solve the questions based on these effects. Okay. So try to listen carefully. Okay. Firstly, I will start with very basics. First, organic IUPAC nomenclature. Yeah. So what is that framework we have? Like there is something called prefix, suffix, like that we have studied now. So what is that? When you are writing the IUPAC nomenclature, what to follow? See, there is a root word. Root word indicates what? The number of carbons in the main chain. How this root word comes? Or what root or root word comes from number of carbons in the longest hydrocarbon chain. Okay. Now, if you write anything here, you are calling it as prefix. If you are writing here anything, that is called suffix. Again, prefix is of two types, suffix is also two types. Okay. So now the name of the compound starts with secondary prefix, starts with secondary and ends with also secondary. So this is secondary prefix, here secondary suffix, here primary prefix, here primary suffix. Okay. Now what is this secondary prefix and primary prefix here? See, secondary prefix means any substituents like branches 2-methyl, 3-methyl, like that we are writing now. Like for example, here if I write like this, what is the name of this compound you are saying? Like how do you number this? 1, 2, 3, 4. This is the longest carbon chain. So what is the root word here I should use? Bute. What is that? Bute. Okay. And its second position we have a substituent now. So you are writing 2-methyl, bute. So this 2-methyl is there now. So that is what our secondary prefix. Now sir, what about primary prefix? See, some compounds are cyclic. Like for example, here I am writing like this. What is the name of this compound? Cyclic it is there. And how many carbons are there in the main chain? 5 carbons. So pent, if I write like this, you are saying this is also pent. But it is open chain, this is a closed chain now. So whenever it is cyclic form, you should mention that cyclo. So now what is the secondary prefix, you tell me first? This is the methyl group right now. So methyl, cyclo, pentane you are writing now. So now what is our primary prefixes here? Something like cyclo, and there are some other compounds called bicyclo or something like spiro. We discussed these names. Okay, this comes under primary prefix. The next root word, the next suffix here. See, what is the secondary suffix and primary suffix? See, if I write like this, OH, same number of carbons, and here I am writing OH double bond. Tell me what is the name of first and second? First. So from where we should number it? Tell me. This OH is a functional group here now. So write the number to that carbon which is attached with this principal functional group. So 1, 2, 3, 4. Here also 1, 2, 3, 4. So now 4 carbons means bute. I hope you know that. 2 means ether, 3 means prop, like that. Okay. Now tell me, bute. Is there like what is the Like, is there any pi bond in the compound? No. So it's alkene. No. So butanol. What is that? Butanol. So you can write butanol. Butane. See, when you're it is on the first group, carbon, no need of indicating one. Okay, butanol. You can directly write like this. What about this one? See, this is you are writing but 2-ene-ol. So but 2-ene-1-ol, or directly you can write ol. See, if you observe, ol is a suffix here, which is indicated by this, indicating this primary principal functional group. Here also ol is there. So this is called now secondary suffix. Now here this is ane, this is ene. So this is also suffix now. See, root word suffix. So what I should say? Here there is ane, here it is ene. So this is what? I can say primary suffix. So something like ane you can say, or ene it can be, or ine it can be. Like this you are writing primary suffixes. Secondary suffix comes from where? Principal functional group. Is this clear, everyone? Okay. Next, let's move forward. We already discussed all these examples, if you remember. Okay, let me give you one or two examples. So identify the proper numbering of these chains, which is correct, 1 or 2. Identify the longest carbon chain. How many are there in the longest chain here? 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. So both of them are having same number of carbons in the main chain. Now consider number of branches. More the number of branches, that will be the parent chain. So here only one branch, here 1, 2. So this is the correct parent chain. Okay, now write the numbering from where I should write? From here or from here? Down? Okay. 1, 2, 3, 4, 5, 6. Tell me now. Second position 1 carbon means methyl. And third position 2 carbons means ethyl. Okay, so now write the name. Gone. See, this is methyl means M, ethyl means E. Which comes first in alphabets? E. So it should be 3 ethyl, 2 methyl, hexane. Hexane. Is this clear, everyone? Right. Okay, can you write for this? First of all, just check whether that numbering is correct or not. If it is not correct, choose the perfect one. How can we number it properly? How many branches are there? If it is followed like pink color numbering, it is 3 branches. Like that you try to give the numbering another way possible if anything is there means. So if I start from here, 1, 2, 3, 4, 5, 6, 7. So same. So this is one chain, this is another chain. 2 branches only. No, 3 is more number of branches. Like that, if I go from here to there, 1, 2, 3, 4, 5, 6, 7. But this completely become one branch. But what we know, more the number of branches. If the parent, when you are deciding a parent chain, if the longest carbon chains are having equal number of atoms, carbon atoms, then consider that parent chain which have more number of branches. So that pink color numbering is perfect. So from where I should number now? From here one or from here? Whatever it is numbered, correct only. Write the name for this. Methyl, M, ethyl, E, propyl, P. Now write. Everyone got this? So once again, 3 ethyl, 2 methyl, 4 propyl, heptane. Okay? Not septane, heptane. Okay. Okay. So how can we select the parent chain here again? See once. Main functional group. Main functional groups, what are those we have, like carboxylic acids, esters, amides, acid halides, all these things we have. Okay. Next, same main functional group, if anything is present like this, both of them are same, means you first prioritize them. Next one, maximum number of multiple bonds. Okay. The next one is maximum number of carbons, maximum number of substituents. Okay. Now what are the things we have here, functional groups? Carboxylic acid, sulfonic acids, acid anhydrides, esters, acid halides. Okay. So aldehydes, what is the prefix we have? Formyl or oxo. What is its suffix? Al, all. Ketones, it can be oxo or keto. Suffix is on. Thiols, suffix is, prefix is mercapto. What is prefix? Suffix is thiol. Amines, amino, amine. Okay, right. So we'll write a few names here itself. Please try to remember this order. Right. Write its name. Fast. Write its name. From where I should start numbering? Carboxylic acid group, carbon 1, 2, 3, 4. Next. What is this? OH. Alcohol, prefix is, what is the principal functional group out of this? Carboxylic acid. See, other than carboxylic acid, like it is principal now, any other functional groups may present, all of them considered like a substituents only. Now just follow their alphabetical order. So what is the prefix for OH? Hydroxy, starts with H. What is the prefix for SH? Mercapto, starts with M. Which comes first? Write the name now. First, 3 hydroxy, 2 mercapto, butane, oic acid. So once again, 3 hydroxy, capital letter first one, 2 mercapto, butane, oic acid. Clear everyone? Okay. So this is a functional group priority. What is the first priority one? Carboxylic acid. Next, sulfonic acids. Next, esters. Esters. What is this? Esters. Next, acid halides. Acid amides, or simply you say amides. Next, cyanides. Nitriles are cyanides. Next, aldehydes, ketones. First aldehydes, next ketones. Hydroxy groups, thiols, amines, alkene, ines. In, ine. Once read this statement beside to this. Oxo is used as a prefix when carbon of aldehyde is included in the parent chain, or else formyl. See, if I count, which is the principal functional group out of this? So start from carboxylic acid, carbon, not from this oxygen. So 1, 2, 3, 4, 5, 6. Yeah, tell me now. We are counting this carbon now. So 6. See, oxo is a prefix when carbon of CHO is also counted. I am counting that also. So 6 oxo hexane acid. Clear everyone? Okay, this is done now. Okay, next, write for this. Fast. What are the functional group? From where I should number? So now tell me what is its name? Tell me. See, 1, 2, 3, 4, 5. So I can simply say pentane 1, 5 dioic acid. Pentane 1, 5 dioic acid. That's it. What is the name of this compound? See, if I simply mention like this, what is it? Benzene. If benzene is attached to something, if that something is parent sign, now this ring should be called as phenyl. What is that? Phenyl. So now tell me. Benzene means C6H6. Phenyl, if I say this is C6H5, it means carbon valency attached to some other thing. See, we know carboxylic acid principal functional group. So 1, 2. 2 phenyl ethanoic acid. That's it. 2 phenyl ethanoic acid. What is the name of this compound? You already written this. See, if benzene with only OH, if these are the substituents, again, I just want to remind everything. Benzene with only NH2. Aniline. What is that? Benzene with only CH3. Toluene. Okay, but out of this OH is more priority now. So now you should call it as phenol with substituents. Now tell me. Which comes first in alphabets? A comes first now. So like this. So this is called isoprene unit. What is this? Isoprene. So write its IUPAC name. See, where do you use this isoprene? See, isoprene is a monomeric unit of natural rubber. What is that? Like polymers chapter you have studied now. So what is this? Isoprene is a monomeric unit of natural rubber. It's a polymer now, so it is monomeric unit. So write its name. From where I should number it? 1, 2, 3, 4. Yeah, tell me now. 2 methyl 1, 3 butadiene. Okay, so which one? Third option. Okay, above one you tell me. Between ketone and cyanides, which is functional group? Priority one. Cyano. Okay, so number it from that carbon. 1, 2, 3, 4, 5, 6. Yes, tell me. 5-oxohexane nitrile. 5-oxohexane nitrile. That's it. Okay, let's move for isomers now. See, what do we mean by isomer? Compounds containing same molecular formula, but they differ in their structure. If they differ in their structure, we are calling them as structural isomers. If they differ in their structure, we are calling them as structural isomers. Now, compounds have same molecular formula, same bond connectivity, but spatial arrangement of atoms are different. What I am saying spatial arrangement means, for example, if this is a carbon atom, carbon has how many valency? 4. See, for example, one isomer is having some 2 different groups here and 2 groups here. Now, one isomer spatial arrangement, if you see, this black color pen is towards you. Now, bond connectivity will be same, but spatial arrangement will be different now. See, black color pen is away. 1, 2, 3, 4, 5, 6. Okay, now, like this I am writing. How do they differ 1 and 2? the parent chain contains here 6, here parent chain contains 5. Okay, A, B, C, D, E. Okay. So now tell me, what do we mean by positional isomers? Isomers which differ in the position of substituents or position of functional groups. Okay. Now tell me 1 and 2, how do they differ? Here 6 carbons are there, but in this how many are there? So 1 and A and B are called now differ in the chain now. So chain isomers. Okay. Now tell me between B, C. See, here 5 carbons in the parent chain, here also 5 carbons. But here 2 methyl, it is 3 methyl. So what I can say? BC are positional isomers. Now what about AC? A and C. Chain contains 6, chain contains 5. So I can say A and C are chain isomers. Perfect. Next, what about CD? See, functional means, what is the chemical formula? It has C6H14. Is there any other functional group, like only single bonds are there, sigma bonds? So they are simple alkanes. If there is multiple pi bond, sigma bonds only, like this means alkanes we may say functional group. But formula is same now, so there is no other functional group here. Yes or no? Are you seeing any functional group like OH, like that? Nothing now. So now C and D, what are they? See, 1, 2, 3, 4, 5 are there. Here 4 only there. How do they differ? They differ in the chain. So C and D. So C and D are what? Chain isomers. Now if I ask A and D, chain only. B and D, C and D, chain. Okay. Now D and E, DE. How do they differ? Parent chain contain 4 carbons, but here 2 methyl groups on the same carbon, 2 methyl groups on different carbon. So what I can say? D and E are positional isomers. They differ in the position of the substance, so positional isomer. Is this clear or not, everyone? So how to identify chain isomer? If the parent chain contain different number of carbon atoms, then that isomers are called chain isomers. Positional isomer means if the position of functional group or substance are different in positions, then we can say. Next one, ring chain isomers. Ring chain isomerism means what? See, for example, you just give me a formula like C4H8 I am writing. So what is this C4H8 means? You just tell me whether it is alkene or alkyne. Alkene you are saying, no? Like you are writing it as Cn, H2n, like that you are saying. Okay, it means definitely this formula contains one pi bond you are saying. Alkene means definitely one pi bond should be there. So now see what I am writing. 4 carbons like this. Okay, next like this. So now tell me, what is the relation between 1 and 2? Position of pi bond is different. So A and B are called as positional isomers. Now what is the difference between C? See, first of all, this is a cyclobutane. What is that? Cyclobutane. See, is it satisfying this formula or not? Yes. So now how this ACR differ? One is open chain and another one is ring. So what is the name of this isomer? Ring chain isomerism. What is that? So one will be having open chain, other will be having so those are considered to be now one more thing you need to identify. When there is, like, see, one pi bond is there in this compound, you should say it as 1 degree of unsaturation. What is that called?
1 degree of unsaturation.
So sir, exactly tell me how to identify how many degrees of unsaturation means. Given chemical formula is there, no? Compare it with the alkene. See, this is a general formula of alkene. What is general formula of alkene? CnH2n plus 2. So if you compare with this, how many hydrogens are less? See, 2 CnH2n plus 2. If 2 hydrogens are less, 1 degree of unsaturation. What I am saying? 2 hydrogens are less, 1 degree of unsaturation. For example, ethane contains how many hydrogens? Ethane, C2H2n plus 2, 6, C2H6, see, C2H6, this is ethane now. Ethene, you tell me, C2H4, C2H2, this is ethane, ethene. So here to here, how many hydrogens are less? So here 1 degree of unsaturation. From here to here, how many unsaturation? How many hydrogens less? Here also 1 degree of unsaturation. But if I compare this with alkane, 1 degree of unsaturation you are saying. Similarly, you compare this with the given alkane. So between alkane and alkene, 1 degree of unsaturation will be there. Between alkane and alkynes, 2 degree of unsaturation. So how you are identifying degree of unsaturation? Comparing the given formula with the alkane general formula. If 2 hydrogens are less, 1 degree of unsaturation, like that. So with this, both of them have how many degrees of unsaturation now? This is 1 degree, this is also 1 degree. It should be satisfied like that. So you got what do we mean by ring chain isomerism? Okay. Next one. Functional group isomerism means what? Different in the functional group. For example, I am writing C3H6O. C3H6O I am writing. See, with this formula, I can write. See, what is the degree of unsaturation it has? Ignore oxygen. Just compare hydrogens and carbons with alkane. See, if it is alkane, CnH2n plus 2 it should be. C3 you are saying C3H6. 2 hydrogens are less means 1 degree of unsaturation. It means this formula may contain 1 double bond or 1 pi bond or 1 ring. Okay. So see here what I am writing, CH3, CH2, COH. What is this functional group? See whether this formula is satisfying or not. 3 carbons, 6 hydrogens, 1 oxygen. See 1 degree of unsaturation, I told now, that is nothing but here 1 pi bond. Okay. So now what is this functional group? Aldehyde. So with the same formula, what I am writing, see CH3, CO, CH3. What about this? Ketone. See, aldehyde ketones are functional group now. So 1 and 2 are what now? Functional group isomers. See, with the same molecular formula, what I am writing? 1, 2, 3, OH. Here I am writing like this. So ABC, now tell me, ABC. What is the relation between ABC? Functional group only. See, this is aldehyde, this is ketone, this is alcohol, enol. So different functional group now with same molecular formula. This is also functional group isomer. Is this clear or not, everyone? Okay. Now I am writing with the same formula. Yeah. Between CD, you tell me what is the relation? Position. Perfect. Because same functional group, but position of double bond is different. Positional isomer. Okay. So now when it comes to amines, CH3, CH2, CH2, NH2, CH3, CH2, NH, CH3. Now what is the relation between A and B, they will ask you. A, B, C. Tell me what is the relation between A and B, B and C, like that. See, to this nitrogen, how many carbons are directly attached? So it should be called as primary. To this? So now they will ask what is the relation between A, B, C. You should say primary, secondary, tertiary amines are functional group isomers. What they are? Sir, they have nitrogen only now. You don't say like positional isomer. They should be what? Functional group isomers. Remember, this is important example. Okay, primary, secondary, tertiary amines are what? Functional group isomers. Next. Okay. here. So what are other things we are still remaining with? Okay. Next one is metamerism and tautomerism. See, two other things are remaining here. First one is what? Very easy. Just follow whatever I am saying. Metamerism. See, with this chemical formula, C4H10O. With this chemical formula, write one structure. For example, I am writing CH3, CH2O, CH2, CH3. So what is this called? Like what is the name of this compound? Ether. Na? It is an example of ether. Like R, alkyl group, oxygen, and one more alkyl group is there. So if it is like this, what you should call? Ethers. Okay, with the same chemical formula, I am writing 1, 2, 3, 4 OH. This is what? Alcohol. This is ether. So if I say this is A, this is B. Between A and B, what is the relation? A and B are what? Functional group isomers. Perfect now up to here. Now see what I am doing. Here I am writing a C, CH3, CH2, CH2, O, CH3. Now between B and C, you tell me what is the relation? Not position. See, to the oxygen of this ether, alkyl groups attached are different. Both of them are ethers now. Here both sides ethyl and ethyl. But here one side propyl, another side is methyl. So metamers are those isomers which have different alkyl groups in the given functional group. For this ether functional group, what are the alkyl groups here? Ethyl and ethyl. But here propyl and methyl. So A, B and C are called as what? Metamers. What they are? Metamers. Remember this. Okay. So now one more example I will give you. So tell me what is the relation between AB? Between AB, A and B. So they differ in what? Here methyl, here it is ethyl, here it is propyl. So what do we mean like relation here? Metamers I can say. Between AC and BC. Between AC. See this is what? Secondary amine. What about this? This one? Secondary. Here it is primary. So what I told you? Primary, secondary, tertiary are functional group. So BC and AC, these are what? Functional group isomers. But this one A and B are metamers. Okay, I hope you got some clarity on what are metamers. Okay, next one. Next one is what? Tautomers. Tautomerism. See, I am writing like this. There is a pi bond, sigma bond, and a carbon here. See, pi, sigma, a carbon here. So on this we have hydrogen atoms now. Out of these three, one I am writing separately like this. Do you have any issues with this? No. So now see what I am doing. A carbon, like what is the valency of this carbon? Any carbon, it should be 4 bonds only. See now what I am doing, oxygen is electronegative now, so pi bond is shifting towards oxygen. So now what is the valency of carbon? See, this bond is going that side now, so it becomes 3 here. So here the alpha hydrogen will be shifted over here like this. See what is happening? CH2 double bond CH. Here oxygen what it is doing? It is taking the pi bond, now it becomes minus. Now what about this hydrogen? Will it be plus or what? Neutral. Plus. Why plus? Because this bond is disconnected from the hydrogen. So H plus O minus. They will make a bond, electrostatic forces. So you can write it as OH. So if you observe, this is like a keto form or aldehydic form. Here it is enol. This is double bond means en, OH means ol. So this is enol form. This is keto form, we can say, or aldehyde form or keto form. So we can say this type of transfer of proton is called keto-enol tautomerism. See, it's not only keto-enol tautomerism. Anytime if there is X, Y, Z, I'm generalizing here. In the place of oxygen, I'm writing it as a Z. In the place of carbon, I'm writing Y. In the place of this carbon, I'm writing X. On X, what we have? A group G, let us say. In the place of hydrogen, I'm writing group G. Mostly G will be hydrogen only. Now what is happening? Since Z is more electronegative, take this bond. Therefore, the valency here is vacated. To that, this G bond is disconnected. So that you will get X double bond, Y, Z single bond. This bond goes with the Z like this. So you can see 1, 2, 3. So like something like 1, 3 proton transfer is taking place. See 1, 2, 3 if I say. From this position to this position proton is transferring now. So tautomerism means simply, how do you remember? 1, 3 proton transfer. Okay, right. Okay, done. Okay, now in the exam question will be like this. This is the most commonly asked question. Which of the following has highest enol content? You know aromaticity? Have you heard about this word aromaticity? Any time? Okay. You don't know about aromatic compounds? Okay, we'll study it once I'm explaining aromaticity. We'll explore this type of questions. Okay. So now, generally what we know, during a chemical reactions, reactants will be there. There will be something called like reactant side. What are the things are there? Substrate plus reagent. This reagent will attack on the substrate, that forms intermediate, finally gives you product side, byproduct. Not all the times intermediates only, sometimes we can call it as transition state. See, when intermediates are forming, generally that reaction is a multi-step reaction. What is it? Multi-step. It means more than one single step it will be taking place. But if I say transition state, it's a single step reaction. Okay, what is the best example for single step reaction? Like you have studied about SN2 reaction now. So it is a single step, leaves two equal halves. So it will be A radical, like that one more A radical will be formed. Okay, so this homolytic cleavage will be favored with high temperatures, like they will mention delta symbol, or with a suitable frequency like H nu they will say, or they will say sunlight. Sunlight, like this they mention. Okay, next heterolytic cleavage, when it happens, tell me? If the bond is more polar bond, like AB, there is lot of electronegative difference. For example, carbon halogen bond is there, or hydrogen halogen bond is there. What happens? Mostly it will be like heterolytic cleavage. Why? Electronegative atom take the bonded electrons, so creates charges like ions, X minus, C plus, or H plus, X minus, like this. Okay, so when electronegativity difference is more. Okay, then after this, we have discussed like first what I am saying, substrate plus reagent. So what are the example, or what we can say that reagents as, it can be either electrophile or nucleophile. So how can we identify electrophile and nucleophile? See, if our substrate is electrophilic, if our substrate is electron deficient, our reagent should be what? See, if our substrate is electron deficient, the attacking reagent must be electron rich. If this is electron rich, this should be electron deficient. So this is how you need to identify which is electron rich site. There you should attack with this electron deficient one. If here it is electron deficient, this electron rich site will go and attack. This is how reaction initiates. Okay. Next. So now what do we mean by electrophile, you tell me? Electrophiles, electron deficient species. Give some examples. Like BCl3, BF3, CO2. See, why BCl3 is an electrophile? See here, BCl, Cl, Cl. Like this we have. So how many electrons are there? 6. It means there is one vacant orbital on the boron. So to this, electrons can be accepted. Okay, so I can say BCl3 is the best example of electrophile. See, phile means attraction, electron attraction. So though there are some species which attract the electrons, so I can say those species as electrophiles. Okay. So now what about CO2? See, CO2 looks like octet configuration is full. That is fine. But what about this carbon? See, it is attached with the electronegative atoms now. So these pi electrons are shifted towards which side? More towards oxygen side, creating what charge here? Electron deficiency, like positive charge is created. Therefore, carbon dioxide can also act as electrophile. Is this clear? Okay. Next, here SO3, you tell me, what about SO3? See, sulfur, like this I am writing. See, try to find their oxidation state, like more positive charge, +6 is there, or this electronegative atom is dragging the pi bond. So it is also electron deficient now. So I can say this is also electrophile. Okay, next one. See, have you seen any charges on them? If I write normally, those are neutral. So you can say neutral electrophiles. Now see here, NO2 plus I am writing. NO2 plus. So first look at those things again. Nitrogen at the middle, oxygen this side, one more oxygen this side, and a positive charge. See here, if you see there, it might be looking like 8 electrons, but again drags towards. So what is the charge creating on this? So this is also electrophile. Is this clear? Okay. Next one. What about NH4 plus? It cannot be a electrophile. Why it cannot be a electrophile? See, sir, positive charge is there now. So we can say electrophile, you might think, but it is not an electrophile. Why not an electrophile? See, if I write nitrogen, how many valence electrons are there? Tell me with nitrogen. 5. So put 5 dots in a simple understanding way. 5 dots are over. Next, this side one hydrogen, this side another hydrogen, another hydrogen. Something like that we got ammonia, like NH3 we got with one lone pair. Right now? Okay. So now I have one H plus ion. See, if these lone pairs are given to H plus ion, so see 1, 2, 3, 4. So 4 bonds are present. How many electrons are there with the nitrogen now? 8 electrons are there. So 8 electrons, there is no vacancy on the nitrogen atom to accept the lone pair electrons also. So it cannot be act as an electrophile now, because it has octet configuration. There is no empty orbital, and nitrogen only electronegative, which can drag the bonded electrons towards itself. There is no electrophilic center. So we cannot say NH4 as an electrophile. Is this clear, everyone? Yeah. Next one. Nucleophile means like they can be electron rich species. Like anything has at least one lone pair electrons on it. Like ammonia is the best example here. Okay. Water molecule, if I write, how many lone pairs are there? So at least one lone pair if present, then I can say these are neutral nucleophiles. See, negatively charged means definitely they have electron rich now, so they can also act as a good nucleophile. See, between these, you tell me which is good nucleophile. H2O, OH minus. Which is good nucleophile? See, which is more electron rich, you tell me? More electron rich, more easily donates the electron. So electron pair donor here is nucleophile. Electron pair acceptor here is electrophile. Like all Lewis acids are examples for electrophiles. All Lewis bases are examples for nucleophile. Clear? Okay. Now tell me about these two things. Here oxygen only, here also oxygen only, nucleophilic center. But who can donate electrons easily? H2 or OH minus? Are see here more electron density is there now. Negative charge is more electron dense than neutral one. So more electron density, more nucleophilic nature. Them are what? Second period. Them are what? Second period element. Second, which period elements? Second period elements. Now what happens from left to right? Electronegativity? Electronegativity increases means they only need electrons. So will they donate the electron? More electronegative atom strongly holds the electron density. So which is least electronegative atom in this? So that will not hold the negative charge effectively as like fluorine. So who can give electrons easily? Okay. So in a period, nucleophilic nature inversely proportional to electronegativity I am writing. Will you accept this statement? How nucleophilic nature varies? Inversely. Why this relation we got? Tell me. See, more electronegative, low tendency to donate. So that's why carbon more electronegative, low tendency. Less electronegative, more tendency to donate. So which is strong nucleophile out of this? So like this you cannot answer. Okay. Next. In a group. So in a group, let us say halogens, F minus, Cl minus, Br minus, I minus. So now tell me, where do we have more effective nuclear charge? Small size, more effective nuclear charge. Large size, less effective nuclear charge. So these lone pair electrons are easily donated. So down the group, what happens to nucleophilic nature? Increases. So halide ion is strong nucleophile, then compare with the fluoride ion. You can write this. So here you just say, what you can say? Electronegativity. How it is related? Less electronegative, more nucleophilic nature. Can write like this. These two orders are important again. Okay. Okay, see here. So now tell me what happens here. See, this is iodine now. Which is more electronegative, carbon or iodine? So the bonded electrons are taken by iodine. So what is the charge you are creating on the carbon? Partial positive charge is created. See, out of this K plus. So now what is the charge you are creating here? Positive. So can I say this is nucleophilic center or electrophilic center? If this is electrophilic center, what should come and attack there? So out of this, which is nucleophile? So that will come and attack here. So that CH3, see this side I going out, from back side OH coming inside. Like this we are seeing. Okay, finally you are going to get CH3 OH. See, here during the reaction path, there is something called here transition state. Sometimes we may also see intermediates. Now what are the types of reactive intermediates we have? Types of reactive intermediates that we studied. It can be carbocation, carbon anion, free radicals, okay, or carbines and nitrines also. But as of your syllabus, you must aware of these three things first. Carbocations, carbon anions, free radicals, the next carbines. Okay. See, when carbocation is formed, see, if there is more electronegative atom attached to the carbon, see, if you break this bond, how you are going to break? Heterolytic cleavage. So now you are going to get CH3 plus. Okay. So now look at this carbon with how many hydrogens? 1, 2, 3 and 1 positive charge. Positive charge is nothing but vacant orbital, vacant p orbital. So how many sigma bonds are there? 3 sigma bonds means what is the hybridization you should say? sp2. Is there any unpaired electrons? No. Electron, like I can say diamagnetic. Is there any unpaired electron? No. And what about electron density? 3 bonds means how many electrons? 6 electrons. 6 electrons. So if we know, if we have 8 electrons, you are saying octet, but here only 6. Electron deficient or rich? Deficient. So I can say carbocations are electron deficient. Okay, therefore all carbocations are good examples of what? Electrophiles. What they are? Electrophiles. Okay, right. Now they will ask you for the stability of carbocations. How can you decide stabilities? See, there are 3 bonds you are saying like this with a positive charge on the carbon. Now what this carbon requires, this electrophilic carbon? It requires electrons right now. If the surrounding atoms or surrounding groups are electron releasing groups, it means already it has only 6 electrons. Now what types of groups can donate electrons into this carbocation? Releasing groups. If they are releasing electrons like this, yeah, this carbon deficiency will be sorted out. Okay, so now what types of groups required here? So carbocations stabilized by electron releasing groups. What they are? Electron. Okay. So tell me, out of these 4 carbocations, which is more stable? We already discussed in the basic classes. Last one, why? Alkyl groups, what I am saying, alkyl groups are electron releasing groups. Okay, so now these are electron deficient. Carbocations are electron deficient. Is there any group that helps by releasing the electrons to this carbon? No. So it will be released stable. What about this? 1 alkyl group is there, 2 alkyl groups, 3. So 3 times it can be stabilized. Okay, I will tell you what are the effects we need to consider there. So what I can say, this is primary carbocation, secondary, this will be tertiary. So which is more stable? Yeah. So the reasons here we'll discuss in the next upcoming slides. Next. Next one is carbon anions. See, carbocations means what is the charge you have seen? See here what I am doing, CH3 with MgBr I am writing. See how it will dissociate, like CH3 minus MgBr plus. So what is the charge present on the carbon? So you can write. So what is the hybridization of this carbon, they will ask. 3 sigma bonds with 1 negative charge. Negative charge is nothing but lone pair electrons. What is it? So carbon anions have sp3 hybridization. See, this is nothing but the structure is almost similar to ammonia structure. Ammonia means how you will write? NH3 with 1 lone pair. Here in the place of nitrogen we just have carbon. Remaining everything is same. So carbon anions have geometry as trigonal, pyramidal. Just a pyramidal you remember otherwise. What is that? Trigonal, pyramidal, or just say pyramidal. Okay. Next one. See, they will ask whether these are electron deficient or electron rich. Rich. See, this small carbon with less electronegative atom having negative charge on it. So can I say more electron density present on it? So therefore, carbon anions act as a nucleophiles. How do they act? Nucleophiles. What do we mean by nucleophiles? Electron pair donors. They donate the electrons. Okay. Now, here, these are also what? React to intermediates. During the chemical reaction, intermediates are formed as carbocations or like carbon anions or like free radicals. Okay. So again I am asking for the basic question, CH3 minus, CH2 minus, like CH3, CH2, okay. So which is more stable carbon anion out of this? Which is more stable carbon anion out of this? Which one? First one. Why first one is more stable? Already they have electron density. Now we required those groups which withdraws the electrons. But what about these alkyl groups? These are electron releasing groups. So electron releasing group decreases the stability of carbon anions. Okay, I will explain with inductive effect later. But just remember what is the order? A, B, C, D, 5, right? A is more stable than B, stable than C. This is reverse of cations. Next, what about free radicals? Same like carbocation, but free radicals are what? Paramagnetic, because free radicals have how many electrons? Yeah. Are simple. These are 4 bonds. If I break this bond giving electrons to hydrogen, you will get a positive charge. This is called carbocation. This is called what? Carbocation. If I break this bond by giving lone pair, this bonded electrons to the carbon, you should say this as carbon anion. See 3 bonds with negative charge on it. If I break this bond homolytically, means 2 equal halves, what happens? Here 1 electron, that will be taking 1 electrons. So 1 hydrogen taken 1 electron. So what is this remaining fragment called? 6 electrons and 7th electron. So odd number of electrons are there now. So these are what? Free radicals. So free radicals means how many electrons are there? Odd electrons, 7 electrons are there here. Okay. So 7 means less than octet or greater than octet? So less than octet means, can I say these are also electron deficient? So which groups will stabilize as free radicals? Electron releasing groups. Here also the stability order similar to carbocation order. Okay, you just remember up to here. Now, what is the magnetic nature here? First 2 are diamagnetic, this one is paramagnetic. Okay, remember this. Next. What is the answer for this question? Tell me. Most stable carbon anion. Third one. If I ask for the order. Huh? 3 more stable. 1. Both of same, no? Let us change this as 3. 2, 4. Okay. This one fast. Free radicals. Free radicals are electron deficient or rich? Deficient means what we where do we have? C. Okay. C, B, A, D. Whatever. Which one? Fourth option. Okay. Next one, we'll study about electron displacement effect, then we'll come back. See, if you just tell me some organic compounds you know. Organic compounds that you know. If you observe, most of the organic compounds contain what? Carbon, hydrogen, along with this something like a halogen sometimes, nitrogen sometimes, high oxygen sometimes. Next what? These are the main elements you will be seeing, sulfur sometimes. Okay. So now the bonds present in the organic compounds will be mostly what? Covalent bonds. What they are? See, organic compounds contains covalent bonds. Okay. So now that covalent bond, for example, that covalent bond will get polarized. See, the electron pair in these covalent bonds may undergo displacements either on their own or under the influence of some attacking reagent. See, on their own means what? See, if there is more electron negative difference, so what happens? It will undergo displacement, electronic displacement like this. Yes or no? So you are going to see like this. Okay? Or it can be influenced or it can be happen in presence of some external reagents, something like this. See, if there is a strong nucleophile, so this will try to attack here. So under the influence of nucleophile also this displacement may happen. Okay? So if this displacement is happening in presence of any external reagent, attacking reagent, then that effect is called electromeric effect. What is that effect? Electromeric. If it is happening on their own without presence of anything, those are called electronic effects. What is that? Electronic. First and most important factor is electronic effect. So electronic effects are of 3 types. How many types? 3 types. So first one is inductive, next mesomeric, next hyperconjugation. So try to listen it very carefully. So please try to listen. See, there is a group G here attached to this carbon side. See, this group G may be more electronegative in this carbon or equal or less electronegative. 3 possibilities are there. So now first thing is, if this is more electronegative, what it will do? The bonded electrons are dragged by this. So if it is dragging, here creates partial negative charge, here it creates partial positive charge. See, since this carbon is now electron deficient, can I say this is electron deficient? Now what it will do? It will show that effect on the neighbor carbon. Something like if you are standing at the beach side, if there is any cyclone or anything like that, what it will do? There will be drastic effect on the beach and little effect like after 500 meters or 200 meters. Like that, as we move away from the beach, what happens? That effect keep on decreasing. Here also inductive effect, you just think like that. There is a group G attracting the electron towards itself. Now what happens? More effect on the first carbon and slight effect on the second carbon. It means I should say with a double partial positive charge. And slight effect on the third carbon. And here on the fourth carbon, it is almost negligible. So inductive effect is a distance dependent effect. What is it? Distance. See, as distance increases, what happens to inductive effect? Are you getting what do we mean by distance dependent means? Okay. Now inductive effect up to works up to how many carbons? First 3 carbons. The 4th carbon is almost negligible. Okay. So what is this? Inductive effect is what? It's a distance dependent effect. It works effectively up to first 3 carbons and more on first carbon. Okay, that's it. So now what type of group I told you this one? So that group you should call it as electron withdrawing group. Which group you should call? Electron. This group is now electron withdrawing group. There is some groups which can be called as electron releasing groups now. Instead of withdrawing the electrons, they may donate the electrons into the chain. Those groups are called as electron releasing groups. Okay, first thing is electron withdrawing group, next one is what? If there is electron withdrawing group, that withdrawing group effect is there now, like it is withdrawing the electrons now, this effect is called minus I effect. What is that effect? Minus I. Or negative inductive effect. Which effect it is? If it is releasing electrons into the system, you should call plus I effect or positive inductive effect. What is that? Positive inductive effect. Okay, next one. Here, sir, how can we decide whether this group, how it is acting as? Okay, see, it's very simple. You just need to compare with the hydrogen atom. If that group attached is less electronegative than hydrogen, then that group acts as releasing group. If that group attached G group is more electronegative than this hydrogen atom, withdrawing group. Okay, for example, all halogens are more electronegative than hydrogen. So therefore they can be electron withdrawing groups. Now to the carbon chain, again carbon with hydrogens are attached. See, between carbon and hydrogen, carbon only more electronegative. Which group is more electronegative? If carbon is more electronegative, definitely now carbon act as C. This is a carbon chain, ma. See, try to understand this. Why I am saying alkyl groups are plus I groups, are electron releasing groups. So to this carbon chain, in the place of G, what I have mentioned here? Some methyl group, let us consider it as an alkyl group. Okay, listen here properly. Who is more electronegative between this carbon and hydrogens? So now this carbon G group is having what charge on it? Negative charge on it. See, this negative charge can be donated into the system. So now all alkyl groups are considered to be donating now. All alkyl groups are considered to be electron releasing groups. Okay, is this clear why I am saying they are electron releasing groups? Yeah, perfect. Next. So now what is the use of studying all these things? I will tell you. Now how many effects I told you? There is 2 types, plus I. So when there is minus I groups means, like see, if this is a carbon chain, okay, here nitro group is attached. Same carbon chain, one cyano group is attached. Same carbon chain, one fluorine is attached. See, here I am changing these groups. Remaining side chain completely same. So which of the following group will withdraw or shows more minus I effect? This is given an experimental order. This is based on what? Experimental order. Who is more stronger withdrawing group? Nitro group, NO2. Then next one? Cyano. Next carboxylic acid. Next aldehydes ketone functional group. Next chlorine, bromine, iodine, hydroxy groups, alkoxy groups, like this. Okay. So which is more here? NO2. Just remember nitro groups, cyano group, fluorine, carboxylic acid, like that you should remember. Okay. So no need of writing, it is there in your modules also, but you should remember this order. Okay. Now how the questions will come on this? I will give you one example. See. Okay, listen here. Out of these two, which is A and B, which is more stabilized and how it will be stabilized? Both of them are carbocations. Carbocations are electron rich or deficient? Electron? If they are electron deficient, what type of groups required? But here, which type of groups we have? See, if releasing group is there, means that will stabilize as the carbocations. But here we have withdraws now, so they will further withdraw the electrons from carbocations. What happens to their stability? Decreases. So I can say carbocation stability decreases by electron withdrawing groups. Can I say like this? Which is stronger electron withdrawing group here? Nitro group. Therefore, it will strongly withdraws the electrons and destabilizes the system more. So it means it will be least stable. So out of these two, which is more stable? B is more stable than A. This is the story of what? Carbocations. Up to here it is clear now? Yeah. Now come for carbon anions. Here both of these are carbon anions. Now tell me which carbon anion is more stable? First one or second one? See, both of them are negative charges. But what about the distance? 1, 2. This is 1. So what we know? This inductive effect is a distance dependent. And carbon anions are stabilized by releasing or withdrawing groups? Nitro group is withdrawing. But effect will be more in which case? More the effect, more is the stability of carbon anion. So which carbon anion is more stable? Is this clear everyone? So 2 is more stable than 1. Clear everyone or not? Any confusions are there? No. Next. Okay. In the same way, we have now releasing groups. What they are? Plus I groups or electron releasing groups. There we have nitro groups, iono groups now. So here, more electron density, more releasing group. More easily it will releases. So O minus and carboxylate ion. Next alkyl group. Like see, you just remember this as tertiary alkyl group. Secondary, primary, and least here methyl. So what do we mean by D and H? D means deuterium, H means hydrogen. So which is good plus I group between hydrogen and deuterium? Deuterium. Okay, it means, sir, what is the exact application of it means? Like see, I am writing CH3 plus CD3 plus. Both of them are carbocations only, but which is more stable, they will ask? CH3 or CD3? CD3, because more plus I group is which one? More effect is for which one? This is releasing groups or withdrawing groups? Releasing groups. And what about our things? Carbocations. What they require? Carbocations are stabilized by what? So we have this electron releasing groups only now. Which is good electron releasing group? D. So that's why it is more stabilized. Okay, that's it. Next one. Out of this A, B, you tell me which is more stabilized? A or B? See, sorry. Which carbocation is more stabilized? Both of them are carbocations. Now what type of groups required? Releasing groups or withdrawing groups? See, O minus, O minus. Both of them are releasing groups only. But what about distance? Very close, very like little far than this. So more close, more is the effect. So which is more stable now? B. Stable than A. Is this clear everyone? Yeah. Okay. So now what are the like applications of inductive effect they will ask? First one is relative stability of intermediates. Just now we discussed carbocation stability, carbon anions. Carbocations are more stabilized by plus I groups. Carbon anions are stabilized by minus I groups. And the next second application is same. Free radicals also follows the same concept of carbocations, you just remember. Next one is acidic and basic strength of organic compounds. For example, you know acetic acid is a carboxylic acid, like acidic compound. Okay. Now to this acidic compound, what I am doing, CH2, CO, OH. Here I am writing fluorine. CH2, Cl, CO, OH. So now out of this ABC, which compound is more acidic, I am asking. Which compound is more acidic? How can you answer this, tell me? Acidic means what? If I say a compound is acid, like HX is an acid, means it should release H plus ion and forms this X minus, right now? So if I say more acidic means this equilibrium should move forward. It means more easily that should release H plus ion, therefore I can say that compound is more acidic. So now acidic nature of organic compounds depends on what types of groups attached. Okay, see minus I groups are there, means minus I groups increases the acidic nature of the compounds. What they will do? Acidic nature of the compounds are increased by which groups? Minus I groups. You might be having, sir, why minus I groups increases the acidic nature? Because after releasing H plus ion, see, just remove the H plus ion. Which H plus ion is more acidic here? This one now. So if you release a H plus, so what happens? CH3, CO, O minus. Like this it is formed now. Similarly here also if you remove this, you will get a negative charge here. Here also negative charge here. So these are called conjugate bases. Acid after releasing H plus ion, remaining part is called what? If that conjugate base is more stable, if this is more stable, equilibrium moves? That conjugate base is stabilized by which groups now? Minus I groups. So stronger minus I group is there, means that compound is more acidic. Strong electron withdrawing group, more will be the acidic nature. So where do we have strong minus I group out of this? Fluorine is a strong minus I group, right now. So which is more acidic here? B. After that, least is A. Everyone clear with this? Clear or not? If not, we will take second example. See. Okay, look at this. 3 compounds I have given. I am asking you acidic nature. What type of group it is, ma? Acidic nature means this proton is acidic here. So what I told you, stronger minus I group, more will be the here what type of group we have? Alkyl groups are what? So plus I group. What about this? How many fluorines are there? 2 fluorines are there, right now? So 2 plus I groups are there. 2 minus I groups, sorry. 2 minus I groups are there. What about this one? 3 minus I groups are there. So where do we have more minus I groups? More electron withdrawing group. So that will make it more acidic. So now what is the order of acidic nature? C, B, A. Clear at least now? Okay. So now if you remember, we have studied something like this. If HX is an acid, then acid, like acid dissociation constant Ka is equals to concentration of H plus concentration of X minus. So higher the value of Ka, greater is its acidic nature we discussed. So what I am saying, acidic nature or acidity directly proportional to its Ka and inversely proportional to pKa. Do you remember this? And acidic, more acidic, low pH also you can say, or inversely proportional to pH. The same question, instead of saying acidic nature order, they may ask you Ka order. What about Ka order? Same. If they ask for pK order, got it now? Okay, remember, we'll come back to this again. Now answer me this question. I know you will easily answer this. Fast, fast, ma, please. Which is more acidic? 2. I just want order. Perfect, perfect. 2, 3, 4. Everyone got this? Because it is more closer, it is distance is increasing, distance far it is, and there is no group here. Right? Clear? Right. Next. What about this one? 3, 2, 1. Perfect. Okay. Next one. Basic nature order also you should remember. What is that?
Basic nature.
What I told you for acidic nature? Minus I groups, more acidic nature. Basic nature plus I groups, more basic nature. So you just remember this statement. Electron releasing groups increases the basic nature of organic bases or amines particularly, and electron withdrawing groups decreases the basic nature of amines. See, if they are electron releasing groups, what they will do? Increases the basic nature. If they are electron withdrawing groups, these statements are reverse in case of acidic character. Okay, that's it. Okay. Now see here what I am saying. Okay, ma'am. A, B, C are there. What is this? What is the degree of this nitrogen? R represents alkyl group. How many alkyl groups are there? 3. So can I say tertiary, secondary? More the number of, like 3 alkyl groups means tertiary, na? What about the nature of alkyl group? So more the number of releasing groups? More basic nature. So which is more basic? 3, 2, least one is 1. Okay, and this statement valid in gaseous phase. Which phase? Or vapor phase. So in aqueous phase the story is different, we will study later, but you just remember up to here now. Okay, 3, 2, 1 will be the answer in gaseous phase. Next. Next effect is what? Mesomeric effect. So mesomeric effect means, for example, SEMA. When I say inductive effect, I have discussed only with respect to the sigma bonds. There is no involvement of pi bonds or conjugation or something like that. But here mesomeric effect includes conjugation. What they includes? Conjugation. So what do we mean by conjugation first? See, there is something called here, a property is there in organic compounds. See, this lone pairs, sigma bond and this pi bond. How do they position? Like alternate now, pi bond, sigma bond, negative charge are a lone pairs. Like this it is mentioned now. So now the delocalization of this electron takes place. See, all the time if you place electrons at a localized position, that is less stable. If these electrons are in conjugative position, like they are moving here and there, that system will become more stabilized. Okay, like this if I write, so now what happens? See, what this carbon is getting now? Lone pair, negative charge, and this single bond becoming a pi bond now. So it should be get a positive charge because lone pairs are giving a positive charge. Like this you can write. Next one, tell me how this negative charge will, see, negative charge, sigma bond, pi bond, again conjugative position, like this. Next tell me, negative charge, O, H. Next tell me, see, I am writing this as it is, this bond also as it is. Now see, this one shift here, it will be going here. Are you getting what I am making there? Okay. So bond here, negative charge here. Finally, see the double bond becoming now again single bond. Okay. So now these structures are called canonical structures. What they are? So how many conjugative structures or canonical structures are formed for phenol? 5. Now if you observe, see, do you remember these positions? If this is a benzene ring with some group G, adjacent positions are called what? This one and this one are called what? Like 1, 2, 3, 4, 5, 6. See 1, 2 or 1, 6. These positions are called what? Ortho. And what about 1, 3 and 1, 5 positions? See 1, 3 or 1, 5 I am saying now. You just take 3 like this now. Just take it like this. M. You just remember it as meta. What it is? Meta. Next 1, 4 para. 1, 4 para. 1, 2 1, 3 1, 4. Okay. Now if you observe these structures, some structures are having negative charges in the ring. What are the structures? Second, third, fourth. But what are their positions? So in 2, 4, you are seeing negative charge or electron density at what positions? Ortho positions. Next, in third position, third structure, negative charge or electron density at para position. Okay. Is this clear up to here how to write these canonical forms and all? Okay. So now this OH group, what it is doing? Is it releasing the electrons into the ring or it is withdrawing the electrons? So I can say OH group is plus M group. What is it? And the effect is called positive mesomeric effect. What is this? See, now there is nothing to discuss about electronegativity. Here any group which has at least one non-bonding electron on it can act as plus I effect. What I am saying? Anything on the benzene ring or any conjugative system, if that G group contains at least one non-bonding electron, then that can act as what type of group? Electron donating group or electron releasing group. What type of group it is? Electron donating group or? So if at least one lone pair is there, we are going to see what type of effect? Plus M effect. Sir, what is the use of studying this plus M effect now? See, you have did that mesomeric Riemann-Tiemann reaction, next Kolb's reaction. Okay, that products formed are there now. That comes from these structures only. I will tell you how it is. See, where do you seeing the negative charges? Ortho and para position. So if there is any electrophile is acting on this, what I am saying? If any electrophile is attacking on these groups, where it will goes now? Electrophile means what is the charge ma? That is electron deficient. And this compound contain where the negative charge? Ortho and para. So that electrophile will be comes to either ortho or para position of this compound. For example, you just take that Kolb's reaction only. We have phenol plus CO2. So tell me what is the nature of CO2, electrophile or nucleophile? Electrophile. See, if this is electrophile and you just remember the reaction takes place in basic medium you have studied. Yes or no? Yeah. So now tell me, this base abstract this acidic proton, okay, and it becomes now O phenoxide ion, like sodium phenoxide ion. So the negative charge is there. It will increases the electron density what positions? Like negative charge where you have seen? Either ortho or at para. See, this is electron deficient and our substrate is electron rich. Therefore, this deficient will attack either at ortho positions or at para. Finally, you are going to get products something like this. OH, like if you add this negative charge over here, carbon should have only 4 bonds. OH, like this ortho product, or it can be para. Sir, how can we decide which is major product here? Yeah, so that depends on again further factors like hydrogen bonding is there. See, between this oxygen and this hydrogen and this oxygen there is hydrogen bonding. That's why this is called as major. Like salicylic acid is major product you are saying now. So why? Because it is having hydrogen bond. Forgot about that, but without knowing the reaction name also you have synthesized these products. Just by knowing that, since this is an electrophile, so electrophile goes to the more electron rich sides. What are the two electron rich sides? Ortho and para. So respect to ortho and para product you have written. Is this clear how you are doing this? Okay. Similarly, if I give one electrophile, again where it goes? Just a normal reaction I am saying, generalized reaction. This compound is there, you just need to add electrophile. Where it can be added? Either ortho or para. So let us generalize this. If there is a group G which is electron releasing group, then electrophile goes to either ortho position or at electron releasing group or at para position. That's it. So I am generalizing this with taking OH as like G. G is now what I am saying? Any electron donating group or electron releasing group. Is this clear everyone? How to decide? Now see, I just wanted to give one simple question. Alkyl groups are what type of groups, ma? This is methyl benzene. So to this I am giving you methyl chloride I am giving in presence of AlCl3. Now what is the product form? Tell me fast. See, what type of group it is? If this is releasing group, it will create electron density which positions? So definitely there might be some charge like at ortho or para positions. I am not saying any mechanism, just I want product. See, negative charges we got here. What about this species? See, chlorine is there, more electronegative. So what it will do? They will drag these bonded electrons towards itself, create some positive charge over here. Right now? So what we are generating now? Electrophile is generating here, like electron deficient species is generating, like our alkyl group. So now what this alkyl group will come and do? It will attack at this electron dense position. So what are the products you may get? CH3 maybe at ortho position or maybe at, okay, that's it. This is how you can directly write the products also without writing any mechanism. But exactly how to identify which is major means, see, both of them are non-polar groups, alkyl groups only now. There is no force of attractions between them. More repulsions are there between the hydrogens. That's why this is minor. See, these are very far now, so minimum repulsions between them. It is major, like this. Okay. Now one more effect is there. Till now what effect you studied? Plus M effect. In mesomeric effect, plus M effect. Now there are some groups, instead of releasing, they will withdraw the electrons from that ring. See, nitro group I am writing, NO2 is there now. NO2 can be properly represented like this. What is this? Nitrobenzene. So now nitrobenzene, if you observe, which is electronegative out of these two? So if oxygen is electronegative, bonded electrons are taken by one more thing. Does this nitrogen contain any non-bonding electrons on it? ఇక్కడ ఏమైనా లోన్ పేర్స్ ఎలక్ట్రాన్స్ ఉన్నాయి ఇట్లా ఆల్రెడీ 4 బాండ్స్ ఉన్నాయంటే ఆల్ 8 ఎలక్ట్రాన్స్ ఆర్ యూజ్డ్ సో దెర్ ఈస్ నో లోన్ పేర్ ఎలక్ట్రాన్స్ ఇక్కడ ఏమైనా లోన్ పేర్ ఎలక్ట్రాన్స్ ఉంటే మీకు ఒక కన్ఫ్యూజన్ రావాలి సార్ ఈ లోన్ పేర్ ఎలక్ట్రాన్స్ కాంజుగేషన్ అవుతాయి సో ఇట్ విల్ ఇంక్రీజ్ ఎలక్ట్రాన్ డెన్సిటీ ఇన్ ద రింగ్ అనే కన్ఫ్యూజన్ రావాలి బట్ దెర్ ఈస్ నో లోన్ పేర్ ఎలక్ట్రాన్స్ ఆన్ ఇట్ నౌ సో డెఫినెట్లీ లుక్ ఎట్ ద అదర్ సైడ్స్ వాట్ టైప్ ఆఫ్ గ్రూప్స్ దీస్ ఆర్ more electronegative, so the bonds will be taken towards that electronegative atom. What is the charge you are creating on this atom now? Plus. If this is plus, see, nitrogen is more electronegative with plus charge, carbon less electronegative with neutral. What happens? Nitrogen won't stop, it will drag the electrons from that carbon now. Yes or no? So now what happens, tell me? That will be dragging electrons like this. So you are creating something like this, nitrogen O minus, this bond here positive charge like this. Yes or no? This is what created from here. Okay. Okay, next what happens again? This pipe conjugation takes place. Okay, what is the charge I should write here? Positive. Again, tell me what happens. This will shift here. Okay, finally what happens, see there is this bond to conjugate here, see if this bond is connecting here again, 5 bonds given back. So again, how many conjugations you have seen? 1, 2, 3, 4, 5, right? Okay. So, but in the previous case you have seen negative charges in the ring, but here it is, again what are the positions for the positive charges? Ortho, para. What charge you are seeing? Positive charge you are seeing. So, I can simply say minus M groups. What groups? Minus M groups are electron withdrawing groups, decreases electron density, at ortho and para positions. Okay, so now which is most electron deficient site in the given in the compound? No, ఈ కాంపౌండ్ లో ఎలక్ట్రాన్ డెఫిషియెంట్ సైట్స్ ఏవి అని అడుగుతున్నాం. పాజిటివ్ చార్జెస్ ఎక్కడెక్కడ క్రియేట్ అయినాయి? సో దోస్ ఆర్ ఎలక్ట్రాన్ డెఫిషియెంట్ సైట్స్. ఓకే, సో నౌ సింప్లీ యూ అబ్జర్వ్ దిస్. Electron withdrawing group is there now. Now I just wanted to add electrophile only. What about electrophile? It is electron rich or deficient? This group is also making electron deficiency in the ring. Particularly at what positions? Definitely ortho para position is very electron deficient. This is also electron deficient. See, both like charges will repel. So it means this group doesn't enter into ortho position or para position. What is the remaining position we have? Relatively meta position is better because there is no negative charge, there is no positive charge. So electrophile in this case goes to which position? In which case when we have electron withdrawing group. Okay, one more thing you need to observe during the reaction, whether it can be plus M effect or minus M effect, negative charges are created at ortho position and para position. Positive charges are also created at, it means mesomeric effect does not act at meta position. It will applicable only at ortho and para positions. If electron releasing groups are there, that increases electron density at ortho para. If electron withdrawing groups are there, decreases electron density at ortho and para. Is this clear everyone? Okay. Now we'll see what are the groups here. See, we have groups like this. How can you remember them? O minus, NH2, NHR, NR2. So this is the order of, like we have discussed about which is strong plus I group, minus I group. Similar to that, which is strong plus M group? O minus. It means more negative charge on it, more easily it will donates into the ring. More ring activation takes place. Okay, like that, this is the order. Okay, right. Rastara. I think it is there in your module, ma. Once check. Page number 177. ఇప్పుడే ప్రింట్ చేసాం చూడండి ఇంటర్. మీకు plus M effect game example ichna phenol. I have given phenol. Here instead of phenol they have mentioned NH2 like this 177 కనిపించట్లే see at least one lone pairs are there, then that group act as what? Plus M group. Okay, now okay, just identify this group whether it is plus I group, plus M group or minus M group. This group, what I told you, to the system, to the conjugative system, if a atom is attached means if it contains at least one non-bonding electrons, then it can be plus M group, I told you. So here at least one non-bonding electron is there, so which group it is? Here you check, does this carbon contains any non-bonding electrons like this? No. And what about adjacent carbon? See, this is more electronegative now, so that will only drag the pi bond towards itself, creating positive charge. Again that will draw the electrons from the ring. So what type of group? Aldehydes, ketones, minus withdrawing groups or minus M groups. Okay, this is the order of plus M groups, and the next one is minus M groups. What is the strong minus M group? Nitro group. Next one is cyanide. Next one is aldehyde. Next ester. No, it is ketone. Next acid anhydride. Ester, carboxylic acid, acid amides, carboxylate ion. Okay, so now what is the use of studying all these things? Yeah, look at here again. This is phenol. What is this called? Phenol. Phenols are acidic. What I am saying? Phenols are acidic. So now when I am discussing about carboxylic acid acidic nature, I used a statement. If electron withdrawing groups are present, that acid will become more acidic. There is no group here. Next compound. Electron withdrawing group. So now tell me which is more acidic? C. Why C? Electron withdrawing group is there. This is very basic. So you can say C, A, B. Okay. Very fundamental I can say here. OH. Okay, fast. Tell me, arrange them based on their acidic nature order. A, B, C, D, E. Which is more acidic? Why C more acidic? Stronger minus M group now. Stronger. Now look at here. When you are doing the questions, identify each groups. All of them are phenols. Down you check methyl, no group, nitro group. So this is minus M group as well as minus I group. When you are doing the questions, apply all three effects. And when you are applying all three effects, which is most prioritized group? Mesomeric effect is more dominating group. It should be playing crucial roles here. So minus M effect is there. Here also which group it is? Minus M and also minus I. What about this group? Carbon is there, aldehyde now. So minus M group, and here aldehyde oxygen is there, minus I group here. Okay, but which is strong effect we have? Like in both effects, nitro group is strongest one, right now. So which is strong withdrawing group? Nitro. So more stronger electron withdrawing group, more acidic it will be. So which is one? C. Next D. E. What about this group nature? It is plus M group as well as plus I group. Here there is no such groups. What I told you, once again repeat that statement. More electron withdrawing group, more is the acidic nature. In three cases we have electron withdrawing group, those are acidic. Here no such group, here electron releasing is there. If electron withdrawing, more acidic, electron releasing, less acidic. No group is better than having electron releasing group. So what I should write? A, B. Is this clear everyone? Okay. Next, one last question. Now tell me about basic nature. What I told you about basic nature, order? Electron releasing groups increases basic nature of amines or whatever the organic basis. See, let me write that structures. NH2 no group, NH2 electron releasing group, NH2 electron withdrawing group. What is the order? B, C. Okay. Fast. What is the order? Again, identify what type of group it is. Strong minus M group, strong electron withdrawing group. Next, what about this group? Plus M group, plus electron, like I can say electron releasing group I am writing here. What about this kind of groups here? O minus. Just check that plus M group order. First one is what? So O minus means strongly ring activating now. So strongly ring activating means strong electron releasing group. It means basic nature will be highest in which case? C case. So C, B, A. Clear everyone? Okay. Remaining we will do in the study hour. Ardham galeda? If electron releasing group is there means its basic nature increases. If electron releasing group is there means what happens to basic nature? So here you check once what type of group here it has. You might be having why basic nature increases, right? See, basic nature means what? Tendency to accept a proton. See, if these lone pairs are easily accepting the proton means I can say strong basic. But what type of group we have here? So that will withdraw these lone pair electrons towards themselves. Now, are they available to accept the proton? Are they available to accept the proton if they are withdrawing this side? If they are not available, I can say least basic. See, here these lone pairs are easily accepting this proton because this group is pushing the electrons upside. So they can easily accept the proton. That's why electron releasing group containing amines are more basic. Okay, so which is more basic? Electron releasing. Next, no group. Least is? Based on this you answer me again. How you are answering? Amma, it's not. Yeah, tell me. How you are answering? More stronger electron releasing group, more will be the basic nature. So that's why C comes first, and here nitro group means least it will be, intermediate B in between. That's it. Okay, remaining things we'll discuss in the study over.